Okay, this example says a man walks along a straight path at a speed of 4 feet per second. A searchlight is located on the ground 20 feet from the path and is kept focused on the man. At what rate is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight? So let's, again, see what we know here and what we need to show and find that connecting equation. So what we know is the man, his rate here is 4 feet per second. Now this one kind of gives a little diagram here. Looking at the picture, it looks like that the way that man's walking here, they're labeling as X. So in our show here, let's label that as dx dt. Oh, that's 4 feet per second. The searchlight is located on the ground 20 feet from the path, so that's known. I'm not going to put that under our known because we're kind of using that on the picture over there. At what rate? Okay, here's our question. So this is our show. At what rate's a rate? It's going to be something dt here. Is the searchlight rotating? So that's along here. How fast is this going to rotate? And that's an angle, so that's d theta dt is what we're trying to find when the man is 15 feet from the point. So that looks like to me when x is 15 feet from the path closest to the searchlight. All right. So what we have to do now is come up with that connecting equation. Notice this one now has an angle in it. So if we got an angle in a right triangle, is that Pythagorean theorem anymore? Nope. This one is an example of one where you deal with trig. So we got to figure out what's the connecting trig equation here. It looks like we have the opposite side and the adjacent side. And so that would be tangent of our angle is going to equal x over 20. And it's okay having that 20 in because that's a constant rate. It's not going to be changing here. So next step, differentiate, find the derivative. Derivative of tangent is secant squared theta. We got to make sure we include d theta dt here. On our other side, you could do quotient rule, but what you have to start recognizing to speed this up and not have to do quotient rule is that we could also do this by taking our x and sliding it out of the fraction. And it's okay to do that because it's in the numerator. If we slide that out of the fraction, now we'd have to replace it with something, which would be a 1. That's just the same as 1/20 x. That's an easy derivative now to do that. The derivative of that would just be 1 over 20. So those kinds of things you got to recognize to speed yourself up and be able to do these faster. But we got to make sure, again, we include the dx dt here. Okay, so now let's fill in and substitute in what we know. We know dx dt is 4. We know we're trying to find d theta dt, so we can leave that in here. The part we don't have to fill in is this. What is secant squared of theta? And we don't have any thetas that we know here either. But what we're trying to do is find the secant squared theta when x is 15. So if we know that this is 15, can we figure out what secant squared of this angle would equal? I think we can, because if we know that's 15 and we know that's 20, we can, even though they don't ask for it, we could use Pythagorean theorem and find that missing side by using a squared plus b squared equals c squared. So we got 15 squared plus 20 squared equals c squared. If you square those and add them, that is going to give us 625. And if you take the square root of that, you're going to find out it's 25. And so we know that this side then would be 25. How do we find secant squared there? Well, secant squared is probably easier to think of if we write in terms of stuff we usually deal with on this. And we know secant's the same as 1 over cosine. So this would be the same as 1 over cosine squared. Well, we can find cosine from this. Remember, cosine is adjacent over hypotenuse. And so we know from here that our 1 over cosine squared then would be 1 over the cosine value, which would be adjacent over hypotenuse, 20 over 25. And it's still squared, so we'd want to make sure that that gets squared there. I'm going to simplify this. 4 over 20 would be the same as 1/5. So now you just got to finish simplifying to get this to the other side. Let's just times it over there. And so d theta dt would equal 20 over 25 squared times 1/5. To simplify that, it'd probably be easiest to actually simplify this fraction inside first before squaring. 5 goes into here 4 times, 5 goes into here 5 times. So 4 squared is going to be 16, 5 squared is 25. Still times is 1/5, and so it looks like the change in the angle here is going to equal 16 over 125. And that would be in the units of something per, I think we were in seconds here, weren't we? Yeah, something in seconds. But what is it? Well, how's the angle changing? They never gave us any units on angles. Well, if they don't give you any units on angles, that's because it's in radians per second. So unless they specifically somewhere mention degrees, you're always in radians.